Hi everyone, this video is an exercise 11D question 1, and in this video I'm going to do parts C and D. So this section is about using reverse chain rule to integrate some functions such that we can always make an educated guess and then adjust that to find the solution. So in this case we have x over x squared plus 4 cubed, and essentially whenever we see functions in the form that we basically have a bracket that has a power, that's normally the case that we basically make an educated guess that, because here the thing is, um, we have x over x squared plus 4x cubed, and the numerator sort of looks like a denominator, not exactly, but looks like the derivative of the denominator. So whenever we have that sort of function that we can kind of see a connection, then chances are it's reverse chain rule. And in this case, and in terms of reverse chain rule, there are mainly two main methods. So one is making the educated guess by having the natural log of the denominator, which is not going to work in this case, because if you take the natural log of this and then you differentiate that, so that's going to be x squared plus 4 and then cubed here. So then you'll have x squared plus 4 cubed, and then when you differentiate that, you're going to have 3 times 2x, and then you have x squared plus 4 squared and so on. As you can see, it's not going to give us this function. So the first case doesn't work, the natural case, the natural log. But the second case is when we basically look at the bracket, and then in this case, first let's rewrite the integral in the form x times x squared plus 4 to the power of minus 3 dx. Now in this case, we take this bracket and add 1 to the power, so we'll get x squared plus 4 to the power of minus 2. Now this is our educated guess. Now let's differentiate it and see how close this is to x over x squared plus 4 cubed. So when we differentiate, we get minus 2 times 2x and then x squared plus 4 to the power of minus 3, which is minus 4x over x squared plus 4 cubed. As you can see, this is very similar. The only thing that is missing is just, actually, we don't want to have this constant of minus 4. So to account for that, we can have a constant of minus 1 over 4 here, and that's basically the answer. So minus 1 over 4 x squared plus 4 to the power of minus 2 plus c, that's the answer to this integration. Because when we have minus 4 here, then that cancels out with this minus 4, so we'll have x over x squared plus 4 cubed. Now it's the same approach in part D, because again, when you use the natural log, this is not going to work, because essentially the order of the power is what basically kind of gives us a hint that natural log is not going to work here, because the order of power is 3, and then when you basically differentiate, you'll have also power of 2, but here it's different. So again, we rewrite this as e to the 2x times e to the 2x plus 1 to the power of minus 3 dx. Now the guess is e to the 2x plus 1. We always add 1 to the power, so to the power of minus 2. Now let's differentiate this. We'll have minus 2 times 2e to the power of 2x and then e to the 2x plus 1 to the power of minus 3, which is minus 4e to the 2x and then e to the 2x plus 1 cubed. Again, as you can see, this is very similar. We just don't want to have this minus 4. So if we have minus 1 over 4, then these two are going to cancel out. So therefore, here minus 1 over 4 is missing. So the answer is simply minus 1 over 4 e to the 2x plus 1 to the power of minus 2 plus c.